Authorities in Greece have imposed a state of emergency following an unprecedented earthquake that has rattled Santorini, the iconic island renowned for its volcanic legacy and breathtaking panoramas. The seismic event, measuring roughly 6.8 on the Richter scale, struck in the pre-dawn hours, unleashing shockwaves across the Aegean Sea and inflicting considerable damage on buildings, roads, and vital infrastructure. According to the Hellenic National Seismological Institute, the quake originated from a fault line situated beneath Santorini's caldera, part of an active volcanic system that last erupted in 1950. This incident has sparked renewed concerns among geologists that the observed seismic activity might be symptomatic of a deeper geological unrest developing beneath the island. In the months leading up to this event, researchers began to notice an unusual increase in underground magma movements paired with a surge in gas emissions. These phenomena have been interpreted by experts as potential precursors to a reawakening of the dormant volcanic system. In response, local authorities have initiated evacuations in high-risk zones, particularly in the picturesque towns of Fira and Oia, where several buildings have sustained significant structural damage. Emergency response teams, together with units from the Greek military, have been deployed to manage rescue operations, provide urgent medical care, and assess the stability of critical infrastructure. Concurrently, the Greek government has issued travel advisories urging tourists to avoid non-essential travel to the island until conditions improve. Santorini forms part of the Hellenic volcanic arc, one of the Mediterranean's most seismically active regions, where continuous tremors can undermine the integrity of the geological framework. Experts caution that persistent seismic disturbances might trigger secondary hazards such as landslides, tsunamis, or even a significant volcanic eruption. Recent geophysical surveys have detected that nearly 3 million cubic meters of magma appear to have vanished from an underground chamber beneath Santorini. This depletion has been linked to the development of a dike, a vertical fissure in the Earth's crust through which magma can migrate laterally, indicating a substantial shift in the island's magmatic system. Advanced monitoring techniques, including GPS and satellite-based interferometric synthetic aperture radar, InSAR, have recorded subtle ground uplift and deformation above the island. The presence of increased microseismic activity, likely arising from rock fracturing as the magma intrudes upward, reinforces the hypothesis that the magma is not disappearing, but is instead redistributing within the volcanic system. Considering Santorini's explosive past, notably the catastrophic Minoan eruption around 1600 BCE, tracking these subtle shifts is critical for forecasting potential future eruptions and issuing timely warnings for both residents and visitors. Ongoing studies involving gas emission measurements and thermal imaging aim to discern whether the magma is actively migrating or if it has settled into a relatively stable subterranean reservoir. A collaborative study spearheaded by leading research institutions, including France's CNRS, the National Observatory of Athens, the University of Patras, and the National and Kapodistrian University of Athens, has recently published a report titled Ground Deformation at Santorini. This work leverages GNSS time series data and preliminary modeling to assess the extent of magma accumulation, evaluate seismic activity, and measure surface deformation. The study places special emphasis on the current seismo-volcanic event at Santorini, offering insights into the dynamics of the underlying magma system and the potential risks posed by ongoing magmatic processes. Compounding these concerns is the situation at the Colombo underwater volcano, located approximately 7 kilometers off Santorini's coast. Research conducted over the past year has revealed a shallow magma chamber beneath Colombo that is steadily accumulating magma. The volume of magma now observed is comparable to the levels recorded prior to its last major explosive eruption in 1650 CE. Given Colombo's history of highly explosive eruptions, exacerbated by the interaction of magma with seawater, the recent uptick in seismic activity around its main crater and several smaller satellite craters has alarmed scientists. Although additional seismic stations have been installed over the past year to bolster monitoring efforts, fragmented data sharing between research institutions and unresolved issues regarding data ownership have hindered a comprehensive analysis of the region's volcanic state. In response, scientists are advocating for enhanced international collaboration, including the deployment of underwater pressure sensors, ocean bottom seismometers, OBS, and gas monitoring stations. Such measures could provide earlier warning signs of escalating activity, enabling authorities to alert marine traffic and ensure that nearby coastal communities are adequately prepared. One of the principal challenges in assessing Santorini's volcanic behavior lies in the inconsistent availability of reliable GNSS data. Continuous and accurate geodetic measurements are indispensable for detecting the subtle ground deformations that signal magma movement beneath the surface. During the heightened volcanic unrest of 2011 to 2012, approximately 10 GNSS stations provided crucial data on caldera deformation, which allowed scientists to model magma accumulation and assess the likelihood of an eruption. However, in the aftermath of that period, many monitoring stations were decommissioned, leaving only 3 operational units. This drastic reduction has created significant gaps in the data, with some stations still appearing on monitoring maps despite uncertainties about their operational status and data quality. Such shortcomings in data transparency complicate the scientific assessment of volcanic hazards, potentially leading to misinterpretations. To mitigate these issues, experts are calling for the reinstallation of additional GNSS stations across key areas of the Santorini region, including the caldera, the Kamari district, and areas surrounding the Colombo volcano, as well as for the establishment of standardized international data sharing protocols and automated data integration systems. These steps would enable more accurate real-time monitoring and quicker responses to emerging signs of renewed volcanic activity. Notwithstanding these challenges, significant ground deformation has been detected at several key monitoring stations. For instance, data from the SN station, positioned closest to the identified inflation zone, indicate a substantial upward displacement, with measurements rising from 60 mm to over 100 mm since mid-2024. Updated GNSS time series data from February 11th highlight 3 critical shifts: a marked upward displacement, a northward drift, and a pronounced northeastward movement that aligns closely with the trajectory of a recent seismic swarm. Notably, a deflationary phase observed around January 20th was abruptly reversed on January 29th, coinciding with an acceleration in surface movement. This increase in the velocity of land deformation suggests that the forces driving the seismic activity beneath Santorini are intensifying. Similar cyclic patterns of magma migration and surface formation have been observed in Iceland, where such episodes have occurred almost monthly since 2007. In one instance, a second seismic swarm, ending on January 25th, was quickly succeeded by a new sequence beginning on January 26th, with the corresponding movements being officially recorded by seismic stations on January 29th. Further geophysical analyses have estimated that roughly 6.5 million cubic meters of magma have accumulated beneath Santorini at a depth of approximately 4.3 kilometers. While this volume may seem modest when compared to the vast magma reservoirs seen in some Icelandic systems, the composition of Santorini's magma is distinctly more viscous and silica-rich. This characteristic enhances the potential for explosive eruptions, as the magma is more likely to trap gases and build up pressure. Ground deformation measurements reveal a maximum vertical uplift of about 90 millimeters and a consistent inflation rate of approximately 33 millimeters per month, underscoring the active accumulation of magma within the system. Although similar uplift rates were observed during the 2011-2012 unrest, which eventually stabilized without culminating in an eruption, the current sustained inflation could be indicative of the magma chamber nearing a critical pressure threshold. Such a scenario might lead to the formation of a dike, trigger further seismic activity, or even precipitate a minor eruption in the near future. A particularly worrisome aspect of the current situation is the potential interaction between the accumulating magma and the existing hydrothermal systems within Santorini's caldera. When rising magma heats the surrounding groundwater or interacts with hydrothermal fluids, it can initiate phreatomagmatic explosions, violent steam-driven blasts that are highly unpredictable. These events can result in the ejection of ash, rapid steam explosions, and even localized tsunamis, particularly in the event of a submarine eruption. To better understand and predict these hazards, scientists are intensifying their efforts through seismic tomography studies, comprehensive gas emission analyses, and detailed thermal imaging surveys. Should the present inflation trends continue, it may become necessary to deploy additional monitoring stations to track real-time ground deformation and provide an effective early warning system for significant magmatic movements. While there is no immediate indication of an imminent catastrophic eruption, the observed disappearance of roughly 3 million cubic meters of magma from the subterranean chamber, potentially signifying its redirection into a lateral dike, raises critical questions about the evolving dynamics of the volcanic system. Current GNSS data suggests that a dike, approximately 1 kilometers in width and 30 kilometers in length, may be forming beneath the surface. However, its measured thickness is only about 10 centimeters, an anomalously small value that necessitates further investigation. To enhance the scope of monitoring, a new GNSS receiver was installed on Nissi Island on February 12, strategically located east of Santorini. This addition promises to provide vital observational data, even as a significant gap in real-time monitoring remains for the Colombo underwater volcano. The lack of continuous data from this critical region hampers the comprehensive understanding of the entire volcanic system, leaving scientists with an incomplete picture of the current state of unrest. These evolving observations lead to a pivotal question. Does the current activity signal the onset of a new major eruptive phase, or is it merely a manifestation of the island's ongoing internal adjustments? Historical records show that previous eruptions, in 1925, 1928, and again in 1950, were preceded by similar seismic and geodetic signals. However, not every episode of unrest necessarily culminates in a significant eruption. Continuous monitoring through satellite-based measurements, ground deformation sensors, gas emission analyses, and seismic activity tracking remains crucial to untangling the complexities of Santorini's subsurface dynamics. Any marked acceleration in these signals could be a harbinger of increased eruptive potential, prompting local authorities to adopt further precautionary measures. In conclusion, while the shifting magma chamber and accompanying seismic activity at Santorini suggest that pressure is building beneath the island's surface, it remains uncertain whether these developments will culminate in another major eruption or simply represent another episode of the island's restless, yet self-regulating, volcanic behavior. Enhanced monitoring, improved data sharing, and international collaboration are paramount to ensuring that any future escalation in activity is detected and addressed in a timely manner. Given Santorini's dramatic volcanic history and the current geophysical signals, ranging from significant ground uplift to the formation of potential dike structures, the prospect of another explosive event, while not immediate, cannot be entirely ruled out. Local authorities, scientists, and emergency management teams are working in close coordination to enhance public safety and maintain vigilance. What does this mean for the future of Santorini? The extensive array of satellite imagery, GNSS data, and seismic monitoring suggests that the island is experiencing a dynamic phase of volcanic activity that warrants close observation. While there is no definitive answer as to whether these signs will culminate in a full-scale eruption, the potential for a violent explosive event, given the silica-rich, viscous nature of the magma, remains a serious concern. As research continues, the integration of new technologies and improved real-time data collection will be essential in predicting any significant changes in activity. In the meantime, local residents, tourists, and policymakers are advised to stay informed and prepared for any sudden developments. We invite you to share your thoughts. Do you believe we may witness another major eruption in our lifetime? Or is this period merely another cycle of minor volcanic unrest? Stay updated on the latest scientific discoveries and volcanic activity by subscribing and enabling notifications for future updates.